Hello everyone. Today we'll continue to talk about GDPs. And in last part, actually we finished to talk about GDP's definitions and how to compute the GDPs from spending side and the production side. So in today's lectures, we would like to talk about the growth rates of GDP, GDP deflator, and how to use the GDP deflator to compute inflation rates, and then what are some shortcomings of GDPs. So let's first begin with the growth rates. So for growth rate, it will actually tell us how fast the variables to proceed. Okay. So for example, when we talk about growth rate, we will use if we talk about a growth rate of x, then we will use xt. That will be the x in the t periods minus x in the previous periods divide x in the previous period and then times 100%. Okay, so this is the way that we can compute the growth rate for x, this variable. Then when we talk about this growth rate, if it's positive, if this growth rate positive, then we will say x is increasing. Okay, if this growth rate is negative, then we will say x is declining. And if this growth rate just equal to zero, then there is no changes. Okay, so there is no changes for x. And this is also the same thing for GDP. So when we talk about the growth rate for GDP, you can see the growth rate of the GDP will show how fast the national income is growing. Okay, how fast the national income is growing. And if when we talk about the GDP growth rate, then we need to change this x variables to GDP. Okay, so we will use GDP in this period. Okay, so we use GDP in this time periods. In this time periods, divide the GDP in the previous periods, and then divide minus the GDP in previous periods, and then use the differences, divide the GDP in the previous periods times 100%. So very similar. If this growth rate is positive, we said the GDP is growing. Okay. And if this growth rate negative, then GDP is declining. If this growth rate here equals zero, then we say there is no changes for GDP. Okay, so this is how we compute the growth rate for GDP. Now let's see to one practice questions about how to compute the growth rate of GDP. You can see here I give you the GDP in 2015 equal $16 billion, okay? And GDP in 2014 equal $14 billion, and ask you to compute the growth rate of GDP in 2015. So how can we do that? So we can just use the formula that we just talked about, right? We need to use the GDP in 2015. That will be $16 billion, subtract $14 billion, right? And divide the GDP in 2014, this part times 100%. So this will give us the growth rate of GDP growth rate in 2015. It will equal 2 over 14 times 100%. If you use the calculators to compute it, then it will nearly equal 14%. Okay, 14%. So this is the way that we can get a GDP growth rate. Now let's look at another example. Okay, how to apply this type of the information. You can see we have two different years, right? 2018 and 2019. So from the first table, okay, from the first table, we have the GDP in 2018. You use the price times the quantity to get a GDP equal 30, right? In 2019, you still use the price times the quantity and then equal GDP. So all in the first table, okay, it shows the GDP in these two different years or equal 30. So how can we get the growth rate for 2019? This is the showing the first table, okay? The first table. how to get the GDP growth rate in 2019. So you use the GDP in 2019, subtract GDP in 2018, divide GDP in 2019, and then times 100%. Okay, so use this part, you can get the growth rate for GDP in 2019, and then it will equal 30, subtract 30, divide 30, right? Times 100%, which means there is no changes for GDP in these 2 years. Okay, now let's look at the second table. So for the second table, things will be a little bit different. You can see in 2018, the GDP still equal 30, right? Use the price times the quantity, 10 times 3 to get a GDP equal 30. But how about the GDP in 2019? You use the 12 because now the price increased, right? You use 12 times 3 equal 36. Now, for this type of the GDP growth rate in 2019, you will equal 36 divide, sorry, minus 30, divide 30, right? So this will equal 20%. Okay, so in the second table, we have the GDP growth rate at 20%. Okay, so this is the way that we can compute a growth rate for GDP. Now, just look at the second table. If we look at the second table, then you might notice in the second table actually the quantity for GDP, the quantity of the products is the same, all three, right? So in the second table, you can see the quantity of the products are equal 3, but the only thing changes is just the price of the product, right? The price of the product in 2018 equal $10. However, the price for the products per each, okay, equal $12. So you can see there are some differences between these two type of the GDP. And this is what we like to talk about, how to get the real GDP versus nominal GDP. So GDP growth actually can change even there is no changes in quantity. Do you still notice GDP growth can change even there is no changes in quantity, just like the second table, right? In the second table, we notice the quantity always the same. However, GDP growth by the growth rate of the GDP in 2019 is 20%. This is what we say. GDP growth can change even there is no changes in quantity. Inflation, okay, inflation, which shows the change in price, can distort economic variables like GDP. So we have two versions of the GDP, right? Look at the second table that I just showed you. No changes in quantity, right? However, the price increased from $10 to $12. This is with the price increase is inflation, right? And this is what it means here. Inflation can distort economic variables in like the GDP. So there are two versions of the GDP we would like to talk about, and this is important. One is nominal GDP. So nominal GDP means we value the output using the current prices. We value the output using the current prices, which means if we want to value the output for 2018, we use 2018's price. If we want to value the output in 2019, we use the prices in 2019. Okay, so this is what we say. For nominal GDP, we value the output by using the current prices. However, this type of GDP doesn't correct for inflation. Doesn't correct for inflation, okay? Because we would use just the current price. Therefore, this type of GDP doesn't correct for inflation. Another type of GDP which we care more would be real GDP. So real GDP value the output by using the price of a base year. So we take 1 year as base year, and we will use the price for this base year for when we compute different periods of the GDP. Okay, so we value output by using the price of a base year, and as we already use a base year price, so no matter which years when we compute a real GDP, we will use all the base year's GDP, all the base year's price. Therefore, for real GDP, it will correct for inflation. It will correct for inflation. So we will talk about one example to that you have more understanding about these two concepts. So the nominal GDP, we use the current price times the quantity. Okay, current price times the quantity. However, for the real GDP, we use the base year's price times the quantity. Base year's price times the quantity. Okay, so this is the difference. And these two formulas will show you how we compute nominal GDP and real GDP. Let's look at this example. So look at this example. It will give you 3 years, right? 2012, 2011, and 2013. We use two products, pizzas and latte. Okay, we use two products. And then for those different years, we have different prices for pizzas, different quantity for pizzas, different quantity for lattes, and different prices for lattes. Okay. Then the first one, please compute the nominal GDP in each year. Nominal GDP, I will abbreviate it as NGDP, okay? So nominal GDP will just use the current price times the current quantity. Current price times current quantity. So how we compute a nominal GDP in 2011? So I said nominal GDP in 2011 would use just the current price for pizza, okay, $10 times the quantity for pizza, 400, okay, plus the current price for that day will be $2, right? And then the quantity for that day will equal 1,000. So if we sum these two numbers, we can get a nominal GDP in 2011 will equal 4,000 plus 2,000. Then we will have 6,000, right? 6,000 for nominal GDP in 2011. Okay. Similar, we can get a nominal GDP in 2012, right? Nominal GDP in 2012, you will just use the current price times the current quantity. So the price for pizza in 2012 increased to $11, right? Times the quantity, 500. Plus, latte's price increased to $2.50. And then the quantity also increased to 1,100. Okay, so here we will have 55,100 plus, that will be, let me see, 2, 5, 11. Okay, so 275. Okay, so we have $2,750 for lattes in 2012. So totally, we will have $8,250 for nominal GDP in 2012. Okay, so similarly, we can also get the nominal GDP in 2013, which will equal, use the current price for pizza, there will be $12, right? And then times the quantity, 600, plus the current price for that too will be $3, and then times the current quantity will be 1,200 units. Okay, so totally here we will have 7,200 from pizza plus 3,600 from latte. So totally we can add the nominal GDP in 2013 will equal $10,800. Okay, so here you can see how we compute nominal GDP. We just use the current price, right, times the current quantity. Current price, current quantity. Here in 2012, similar. Okay, we use the current price times the current quantity. And then in 2013, still similar. Okay, current price current quantity, current price, current quantity for both pizzas and latte. So similarly, okay, we can get those nominal GDP for different years. Now, let's see. Please compute the real GDP in each year by taking 2011 as the base year. So here in this question, it already told you how we will compute the real GDP because it already gave you the base year. Which year is the base year? So in the future, maybe homework assignments, quizzes, or some practice questions, you need to pay attention which year will be the base year. Okay, so questions will tell you which year will be the base year. And then that will be changes how we compute the real GDP. If we, for example, in this question, we use 2011 as the base year, then we'll compute the real GDP based on 2011's prices. However, if there are some questions we use 2013 as the base year, then you will compute a new real GDP based on 2013's price. Okay, so let me show you how we can compute the real GDP. So for real GDP always abbreviated as R. Okay, real GDP use their base year's price. Okay, we use base year's prices times the current quantity. Base year's price times the current quantity. So for example, the real GDP in 2011, okay, real GDP in 2011, it will equal the price in 2011, okay, for pizza, $10, okay, times the quantity, 400, plus the price for latte will be $2, and then times the quantity. So we will have $4,000 plus 2,000, and then we have the real GDP in 2011 still equals $6,000. And you probably might notice that this number is exactly the same as nominal GDP. Why? Because this year is just the base year. Okay, so for base year, nominal GDP will equal real GDP. Okay, but now let's see something will be different in real GDP for 2012. We will still use the base year's price for pizza, which means here we'll use $10 for pizza. Okay, $10 for pizza because this is the base year price. Okay, times the current quantity, 500, plus base years for latte's price will be $2, right? And then we will times the quantity, 1100. So here we will have $5,000 plus 2200. So totally, the real GDP in 2012 will equal 7,200. Okay, and then you will notice this number actually is different from what we just compute by the nominal GDP in 2012. Now let's see how we can get the real GDP. The real GDP in 2013 will equal, still use the base year's price for pizza, okay? $10, okay? And then we have the pizza quantity in 2013. This will be times 600, okay? This is just the current quantity, okay? Plus base year's latte price, $2, right? And then times the quantity in 2013 will be 1,200, okay? So finally, we can get the real GDP in 2013 will equal 6,000 plus 2,400. Okay, so finally we can get the the real GDP in 2013 will equal 8,400. Okay, 8,400, and that will be different from nominal GDP. Okay, so this is the way that we can compute for real GDP. You can notice when we compute for real GDP, we all use the base year's price. So you can see the base year price, the base year price, the same, okay? The base year price keep the same thing, okay? Keep the same. However, the quantity will be different. And this is the key way that we can distinguish nominal GDP and the real GDP. We'll say why real GDP can correct for price, because you can notice all those real GDP in 2010, 2011, 2012, and 2013, we all use the same price. And this is what we say real GDP can definitely correct for inflation because there is no changes in price for these two products. So you can see this is the way that we can compute for the real GDP in different years by using 2011 as the base year. Okay. Now let's see. This table will just summarize what we compute. Okay. For this example, we have nominal GDP, right? And then we also compute a real GDP based on 2011 as the base year, right? So let me just summarize what we compute. In this table, you can notice it still gives you different years, right? 20 from 2011 to 2013. And then let me show you this table. So for the year, we have 2011, 2012, 2013. We have the nominal GDP, right? And then we also compute a real GDP. So nominal GDP in 2011, $6,000, right? And as we just compute, we also have the real GDP equal $6,000. However, in 2012, we have nominal GDP equal $8,250, right? But the real GDP, as we just compute, is 7,200. Okay. In the year 2013, we have the nominal GDP equal $10,800, right? However, the real GDP, as we just compute, it will equal 8,400. So you can notice in each year, okay, nominal GDP, those nominal GDP measures by the current prices, measures by current prices. But the real GDP all measures by a constant price. If we use 2011 as our base year, so this is the base year up here, base year. So you can see for the real GDP, actually it measures the changes in quantity, but not the changes in price. So the changes in nominal GDP, the changes in nominal GDP reflect the changes in both prices and quantity. Okay, reflect the changes in both. This changes. Okay, this changes. $2,250, the differences between nominal GDP of 2012 to 2011. These changes reflect not only the changes in prices, but the changes in quantity, okay? However, the changes in real GDP, the changes in real GDP only reflect the changes in quantity, not the changes in price, because we will all use the same price but different quantity in each year. Okay, so the changes in real GDP is just shows the changes in quantity because it has no inflation. It has no inflation. Okay, so this graph will just show you for the nominal GDP and the real GDP. You can see if we use the year 2005 as the base year, if we use the year 2005 as the base year, you can see both real GDP and nominal GDP is the same for the year of 2005, right? But however, after that, you can see there is a gap. there is a gap between real GDP and nominal GDP, and that gap actually reflects inflation. Okay, the gap actually reflects inflation. All right, so real GDP, as we just talked about, it can adjust the GDP for price changes because real GDP already corrected for inflation. And this is we will care real GDP more than nominal GDP. Now we would like to say how we can use the nominal GDP and real GDP to compute for GDP deflator. Okay. Here for the price level is just an index to measure the price of the goods and services in an economy. So example to measure in price level could be the GDP deflator. So how can we get a GDP deflator? This is also an important concept in this chapter. GDP deflator, very easy to compute. We will just use the GDP deflator to deflate out inflation from nominal GDP so we can find out the real GDP. And this is the way that we can compute the GDP deflator. So GDP deflator, okay, very easy to get it. Deflate, you can see GDP deflator will just equal nominal GDP divided real GDP and then times 100. Times 100, not 100%, okay, times 100. This should be keeping in mind. GDP deflator will use nominal GDP divide real GDP and then times 100. So if we have the GDP deflator and then ask you to compute a real GDP, then how we can do that? Actually, from this one, we can derive the real GDP would just equal nominal GDP divide GDP deflator, okay? So that is one way we can derive from this formula, okay? So real GDP would just equal nominal GDP divide GDP deflator, okay? And then for nominal GDP, it will just equal real GDP times GDP deflator, okay? And we always use the GDP deflator also to compute the inflation rate. So I would like to talk about that part later. So one way to measure economy's inflation rate is to compute the percentage changes in GDP deflator from one year to the next. So this is what we can use GDP deflator to compute the inflation rate. So let me see inflation rate. How we can get inflation rate? As it's showing from this formula, okay? So first, if we want to get an inflation, let me just write down here, okay? If we want to get an inflation rate in the year T, okay? In this year, we need to use a GDP deflator. I'll just put GDP deflator, okay? In this year, subtract GDP deflator in previous year, okay? And then divide the GDP deflator in previous year times 100%. Okay, so from this formula, it can give us the inflation rate, okay? The inflation rate. I would like to show how to use these two formulas in the next examples, okay? So let's see. This is what we just compute, right? From the pizzas and lattes combinations for each year. So in 2011, okay, for 2011, we can get the nominal GDP and real GDP, right? So how we can get a GDP deflator? We just need to use the nominal GDP divide the real GDP times 100 to get a GDP deflator, right? So let me show you how we can get a GDP deflator first. So the GDP deflator will just equal nominal GDP divide the real GDP times 100, right? So for first one in 2011, okay, we have the in nominal GDP equals 6,000 divide real GDP 6,000 times 100. So which will give you a GDP deflator in 2011 equal 100, okay? And then this is the GDP deflator for all the year, which we use as the base year, okay? And then in 2012, still, okay, we use the GDP deflator, nominal GDP, 8,250 divides real GDP times 100, okay? And then to get the GDP deflator, okay? Which will equal 144.58. All right. And then in 2013, okay, similar, okay, in 2013, we will still use the nominal GDP, 10,800 divides the real GDP, sorry, 8,400, okay, times 100. So finally, we can get the GDP deflator will equal, sorry, will equal 128.128.57. Okay, so here we can get a GDP deflator in each year. Then how we can get the inflation rate based on the GDP deflator? So this will be GDP deflator. I just put it here. This is GDP deflator in 2011, right? And this will be GDP deflator in 2012. And then we also have a GDP deflator in 2013. All right, so how we can use these numbers to compute inflation? If we want to get inflation, if I want to get inflation rate in 2012, then how we can get? We need to use the GDP deflator in 2012. That will be 144.58. Subtract GDP deflator in 2011, divide GDP deflator in 2011, and then times 100. And this will gives you inflation rate in 2012 will equal 44.58. Okay, so this will give you a GDP, or will give it an inflation rate in 2012. So similar, we can get inflation rate in 2013, okay, which will equal GDP deflator in 2013 is 128.57. Subtract 144.8.85 or 0.58 as the GDP deflator in 2012. Okay, divide GDP deflator in 2012 and then times 100%. So from here you can get, from this part you can get the GDP inflation. The inflation rate in 2011 will actually equal negative 11.26. I remember, if my memory is correct. Okay, so you can see here we can compute the inflation rate based on the GDP deflator. Okay. Oh, this is 0.07. Okay, 11%. Okay, 11%, negative 11%. Okay, so this is the way that we can compute inflation rate based on GDP deflator. Now there are something to note. Okay, first, GDP deflate. GDP deflator deflates the nominal GDP to real GDP. And GDP deflator is 100 for base year. Okay, it's 100 for base year. You can notice here we use 2011 as the base year. So we have GDP deflator will equal 100 in base year. And negative growth rate of GDP means output decline, production is not good. If nominal GDP growth rate larger than real GDP growth rate, which means price increasing, okay, price increasing and inflation will be positive. Inflation will be positive because nominal GDP doesn't correct for price, but real GDP correct for inflation, right? So if nominal GDP's growth rate larger than real GDP's growth rate, then we can have the conclusion that inflation is positive. Okay, so there are always three major usage of GDP data. So, for example, we would like to use, and then we would like to talk about why GDP were useful to exam, because GDP can use to estimate the living standards across time and nations. These years, you might notice, okay, the GDP for USA, the GDP for China, the GDP for Germany, the GDP for Japan, right? We use GDP as a broader, as a big indicator, okay, for the living standards across time and nations. And we use the GDP data to measure economic growth. Okay, so we can compute a GDP growth rate and then to talk about if the economic growth is positive or negative or no changes. So this is another usage of GDP data. Next one, we'll use GDP data to determine whether economy is experiencing a short-run expansion or recession. So currently, you might hear from even from news, right, online, or maybe from TV. You will say, okay, the Q1 or Q1, Q2 GDP. You might notice these two. Q1 means quarter one. Q2 means quarter to the second quarter of the year. So for second quarter, the first quarter of 2022, you will notice that we say the GDP growth rate is negative. Okay. And then for the previous quarter, the second quarter of 2022, the GDP growth rate still negative, which means we can use this GDP data to talk about, okay, our economy maybe experience a short run recession because we have negative growth rate of GDP. So those are the three major usage of GDP data. However, for GDP also have some drawbacks because the GDP doesn't include the non-market goods. We only compute it. If you still remember the definition of GDP, we use the GDP to compute the final value, the market value of all the final goods and services, right? So it doesn't include non-market goods. For example, washing dishes at home, mowing a lawn at home, okay? Or for example, there are some parents, okay, stay at home to take care of the children. Those stay at home parents, their contributions to the family actually doesn't count it in GDP. So in less developed society, well, house products or house produce many of their own goods, but GDP could be a very poor measure for those economic output. For example, the things that I grow in my backyard, the tomatoes, the cucumbers, the zucchinis, the peppers that I plant in my backyard actually doesn't count for GDP, right? And in less developed countries, in less developed societies, those type of outputs could be substantial. However, those type of output doesn't including in GDP. And this is what we say, GDP doesn't including the non-market goods that should be create some buyers calculations of GDP. This is the first shortcomings. Now let's look at the second shortcomings of GDP. It doesn't including the underground economy, or we call it shadow economy. So the hidden or uncounted transactions, sometimes illegal, sometimes illegal goods, transactions were also not included in GDP. And sometimes the legal goods were also not included in GDP. For example, the waitress tips that were not included in GDP because those tips probably were out of tax, right? Something illegal, for example, exchange of the narcotics. Okay, so those are not legal transactions and were definitely not included in GDP. This, do you know the size of the underground economy? Do you know that? The size of the underground economy could be very huge. It will be 10% of the GDP, 10% of GDP in the United States. Could be, okay? Do you know how it would be in the less developed countries? It could be 55% in developing countries, 45% in developing countries, and smaller in United States because due to we have very strong economy and then consumption. However, you can see here the size of underground economy could be substantial, could be huge in less developed countries or even developing countries. Now let's see another shortcomings of the GDP. It comes from GDP doesn't measure the quality of the environment. Because GDP is just a number, right? And then we just use the price times the output. We don't have any indicators for the quality of environment in our GDP. So GDP is unable to distinguish how goods are produced. So for example, in the United States, the goods could be produced in more energy efficient way, right? But the things that produce in developing countries or less developed countries will be more labor intensive or more pollution involved. But GDP doesn't count it for that part. We will just look at price and quantity, right? So GDP is unable to distinguish how goods are produced. You can see for country A, we have 10 million units of outputs, but country A will have clear energy and clear air. Okay, we have better quality of environment. However, in country B, still has 10 million outputs, 10 million outputs. However, it will involve in no environmental standards and then also involve some health issues. So you can see if we look at the GDP data, country A and country B, they have the same outputs, right? 10 million outputs. However, GDP cannot count it for environmental standards. So you can see these two countries, they have equal GDP, but is it the well-being in these two countries the same? Definitely not. Okay. Now let's look at the last part of the GDP shortcomings. It comes from leisure time. GDP, as I just mentioned, we will use the price times the quantity, right? So just price and the quantity. There is no leisure times or including in GDP. So GDP doesn't capture how long it would take to produce goods and services. So just as the previous shortcomings, GDP doesn't count how products are produced. It also doesn't count how long it may take to produce the goods and products, right? So you might notice for average work week in different countries, in South Korea, the people need to work 46 hours per week. This is for South Korea. In Netherlands, people just need to work 28 hours per week. For the US, average people work 36 hours per week. Even for those different countries, okay, if we assume those hours can produce the same output, then you can notice that living in Netherlands could be more happy, right? Because it will involve shorter time, right? And then it will have more longer leisure time. So this is what we said. The GDP actually is a good indicator to measure the economic growth, but it also has its own shortcomings. Therefore, there are some economists that suggest some alternatives for GDP, okay, to measure the economic well-being. Some Other measurements might including life expectancy, okay? Might including education levels, and then how easy to access for healthcare, and then for the how high or how low will be the crime rates, and then how better, okay, is the environmental quality, okay, quality, okay. So those are some indicators that nowadays the economists try to take into account when we consider not only GDP, we also need to consider other indicators that could be better to measure the whole well-being of the society. However, in in reality, we know those indicators are really good. However, they are difficult to make it quantity. Okay, GDP is still easy to be quantity because we just need to get a price, get a quantity, right, and then we times it, multiple, and then summation to get a GDP. However, for the education levels, for the access to healthcare, for the crime rates, especially for environmental quality, different countries have different standards. So those alternative measures are very difficult to quantify. Okay, so now let's look at several practice questions. The first one could be GDP measures a nation's exports, a nation's debt, the nation's income, or the nation's consumption. Which one could be correct? Remember, the title of this chapter will be Nation's Income, right? How to measure nation's income. So GDP measures nation's income. Why doesn't GDP count expenditures on intermediate goods? Why doesn't GDP count for intermediate goods? Because it will result in double counting, right? The intermediate goods are already included in final goods, right? So why we don't count the intermediate goods? Because we want to avoid double counting. Now, what's the biggest components of GDP in United States? What's the biggest components of GDP in United States? First, I need to ask what are four components of GDP? We have consumptions, investment, government spending, and net exports, right? In United States, consumptions takes the largest part. So consumption is correct. Okay, now that's the end of chapter 10. Talk about how to measure nation's income by using GDP. Thank you so much.